Oh yes, I do have Wi-Fi.
Nice.
Okay, did you get your answers, homework?
How do you,
Okay.
okay, for number three, how do you find the bounds?
Number 3. Well, I don't know what's the question. What was the question?
R equals 3 minus 2 sine theta.
Minus cosine theta?
Minus cosine 2 cosine theta.
Bob
Two.
shows you the bound.
Oh, 2 sine theta.
Why do you have the length of my spark mixer?
It's cute, like a ball.
Just do 0 to 2 pi.
How do you know it's 0 to 2 pi?
It's just that's how you go around the whole thing. So that's here's the way they calculate area. I figure out how to do this. So and this is A. So this is how do they calculate areas? So 0 to 2 pi. Oh, this is so cool. I think 0 to A. And the A, wait, what's the A? A is gonna be 2 pi, so let me do 2 pi here. Play. Does that make sense? So the way you just use data and then cut out the data to infinite amount of sections.
So it's 2 pi.
And I just figured out the stop period, which is cool.
Wait, can you do like the graph on like cosine 2 theta? Cosine 3 theta?
R equal to cosine 2? Okay, R equal to what?
Cosine 3 theta?
Cosine 3 theta?
Because I want to see.
You want to see
I
the
wanna see, like,
same way?
I want to see how like a double traces.
Okay, so fine. I think that's a good idea. 0 to A.
Can you put like a coefficient? Yeah, can you put like a coefficient at the beginning so it's bigger?
You just zoom in.
Or that?
Actually, it doesn't show double traces. Why? Do they stop at pi? They stop at 2 pi.
You zoom in.
Okay, no, hold on a second. Zoom in. They should show.
No, because the theta, the balance there, the balance is the boundary that shows, but not like the traces.
Oh, okay.
So they're technically the theta on the bottom. What's like the? Why does it like stop moving? Why isn't it continue?
Well, but they should have calculated this. It should be like this and going this way. Do you see what I'm saying?
No.
It should go in this way, like this. This is how it's supposed to go. Oh no. Oh, I see. They okay.
They just go around in circles. It's not like the actual
Yeah, but this one doesn't. Okay, so I'm trying to say is. So if you do R is equal to cosine of 3 theta,
I think
and if you do 0 to A here, it's not matching. Do you see that? See that part is not counting area?
look at traces part of it before it like right there.
See that part is not counting?
Yeah, I mentioned.
Weird. No, double trace. Like it's
Double tracing before couldn't.
no. So
Yeah.
I'll ask another thing. So it's,
I see what you mean. Because the shading isn't like what it's tracing, it's just going in circles.
Oh, I see what you're saying.
So that's why there's the empty space, because it's on the other side then. So it's not like going over in a circle.
Pretty cool.
What function is like the tracing? Like how do you get the inside shaded?
You just do that. So if you do left side, we'll show you the area.
Oh, so the less than, the inequality doesn't appear because the inequality going like this the whole time. So it's not gonna get there until it completely goes. Okay, that makes sense. Okay, is this okay?
But if you do greater than,
It's gonna be outside.
That's cool. William.
for that kind of like visualizing.
Yeah. Okay. I see. I see what you're saying. Maybe I. No, I cannot do. I can do a different color. Hold on. Change to a green. Wait, this one has to be. This one has to be less than.
Oh,
Wait, it didn't share anymore. This one's not A.
Yeah, there's that's
Ah, there we go. Wow. Rebuff, I'm gonna ask you to leave. You can mess with me. Okay, so this is actually pretty interesting. So we're gonna go to the next graph. So let's go to let's go to this graph here. So this graph is R equal to 1 minus 2 sine theta. And the question says, can you find the area of the inner loop? And can you find the outer loop?
Find that the area.
Yeah, find the area of the outer loop. And can you find the area between the inner loop and the outer loop? Okay, so so what we're gonna do is we're gonna start looking at this question. So let's graph this, or well, let's not graph this. We cannot graph this by hand, so we're gonna just go in from here. We're gonna say, okay, 1 minus 2 sine theta, R equal to 1 minus 2 sine theta. 1 minus 2 sine theta. Okay, so it's gonna be this graph here, right? And I want to find, first of all, I want to find the area of the inner loop. And I want to find the area of the outer loop. And I want to find just this part. Just this part. Which is one thing subtract the other. But how do I find the area of the inner loop right here? Well, it is like a pedal, but from how do you just specifically find that's area from this part? So there was two ways around that. I mean, there's one way around, at least I know of. One is what? How do I just find the area of inner loop? That just says this part here. Maybe I'll do it two separate sheet here. So how do I find the area of the inner loop?
like from negative.
I need to focus. Focus.
I'm not doing anything. So,
Yeah, Reebok.
I'm trying. Literally not my fault.
Okay, how do I just find the inner loop?
Can I see how it's traced?
You want to see how it's traced? Sure. Let's go with A.
I think that's it. So
so it's gotta be from like
It-
5 or 6 to like
something like that, yeah. I think like starting now, that
First of all, you need to know how to use your graphing calculator. So get your graphing calculator, ever do the same thing. Of course, you're not able to trace it, but you can actually just graph the inner loop. How do I just graph the inner loop?
I think it's that function from like what Jared said, like 5 or 6 to like
Maybe it's not 5 or 6.
not
So
enough. It'd be like
yeah, it's 5 or 6 to something.
That's the art.
5 or 12, because it's double.
5 or 6.
I was thinking
Five.
5 hours.
Yeah. So what you can do, you can set the r equal to 0, right? Because you really, the moment it crosses zeros is the moment I'm interested. So it's gonna be 1 minus 2 sine theta is equal to 0. So 2 sine theta is equal to 1. Sine theta is equal to 1/2. And the theta must be equal to pi over 6. And the theta must be equal to 5 pi over 6.
Oh, yeah, it's not too big.
So that means integration between pi over 6 to 5 pi over 6, that is going to be the inner loop. Does that make sense?
Wait, why is R equals 0 for this one?
Because that's when the r equals 0 is right here, because there's no radius. Because
Okay.
that's when they trace back to the 0.
Yeah.
So the first time it traces back to the 0 is like here.
Mhm.
And that's roughly at pi over 6. You can see it from here. Going from here to, okay. And this is 5 pi over 6.
Mhm.
And so it intersect twice here.
Wait, how do we know that's 5 pi over 6?
Yeah,
Or that's 5 over 6?
Because you said 1 minus 2 sine theta equal to 0.
Okay, okay.
Okay?
Yep.
Is this okay? So far I can do that. So this is called the inner loop. Okay. So how do I find out the outer loop? Well, the outer loop is going to be integration of 5 pi over 6. The outer loopers start at 5 pi over 6, right? But they didn't need to go through 2 pi's. So that's going to be 13 pi over 6. And 1/2 of 1 minus 2 sine theta squared. So that is going to be the outer loop. Is that okay?
Wait.
Because you're going from 5 pi over 6 all the way going around. So if I just stop, like, let's just say, if I just say, this gonna be the 5 pi over 6, so 5 pi over 6, and this one is gonna be 13 pi over 6. 13 pi over 6 is gonna, you should see that, where was my A slider?
You have to press play.
Oh, I press play. Okay, you're right.
Oh, okay.
Wait, why is this one is 5 pi over Oh, 5 pi over 6 is already including that. So they will trace all the way back there. Is that okay?
You want me to start?
So, how come like
I made it the initial number bigger.
so it's tracing over back to 0?
Because if you make the
Yeah.
initial number
Like
anything
when,
greater than
when the slider
Jared, hold on a second. You can do that afterward.
when the slider is like at the far right, like at the end, that's like where it's back at 0.
Yeah, here.
Yeah. So it like traces over that.
Yeah, it traces over all the way back to here.
Okay.
Because this is the original graph that's there.
Mhm.
And then they will have that already, but it's gonna trace all the way back to the 0. So you can find the integration of the outer loop. And if you take the outer area minus the inner area, right, inner loop, then you will get the area between the loops, which is you're gonna get this area here without this part. Does that make sense?
What does it say? What's the bounds for the outer loop? Is that pi over 6 or 5 pi over 6?
5 pi over 6 to 11 pi over 6. Because you start at the 0 and you go all the way around to the next 0. So it has to be 13 pi over 6.
So then, can you show the slider going from 0? Wait, can you show it going from pi over 6 to 5 pi over 6?
Pi over 6 to 5 over 6. Yeah, that's going to be the inner
The
loop.
inner. Okay.
So this one is 5 pi over 6. So that's gonna be the inner loop only.
If you make the initial number bigger than the coefficient on the function, then it'll never be 0. It'll never be the same. Yeah. It'll never.
Is that okay? Okay, today in class, where's Austin? I thought I saw him.
He's disappeared.
I swear I saw the kid.
He was here.
He was here, right?
I think so.
Where's Austin? Always.
Like maybe both.
Was he here or not here?
He was here.
Oh, it does both. It's like, whoa.
That's pretty good.
I swear I saw him. Or I'm just dreaming. I know you guys are lying to me. Okay, so today your objective is this. Your objective is to find out R equal to -6 cosine theta. So that is the first. Oh, there's Austin. I didn't see it.
He was just here. Oh.
2 minus. I just call you 2.
You good, bro?
Okay, so I want you to graph those two functions. So I'm gonna graph it for you. This one is this graph, I believe, and I don't know, not that one. So today your classwork, you're gonna be able to find the area between the overlap. Garrett, I need you to find the area overlap.
How do we graph like polar on this?
You just go mode, change the polar, and then change the data from the data min, data max on window. So your goal today is before you leave, is you gotta find the shaded region. You have 30 question multiple choice today about AB exam. No, BC exam is multiple choice. So you guys need to practice multiple choice.
Wait, somebody has like the bound like from 0 to like 2 pi on here. I don't know how to get rid of that.
You change that window.
What?
Window. Okay.
Wait. Window settings?
You gotta find the overlap region. And that's what the AP exam is gonna look like. Jerry, can you teach him how to change the data?
No, it's already in data. I just need to. There's like bounds at the bottom, like.
Yeah, change it. Data min, data max.
Oh, so you want me to check?
Go.
You just.
So I'm not gonna give you an answer here, unless you got it right. So I want you to find the area region overlap. So this region I'm look at interest before you leave. Yep. You guys gonna be help each other find out the region overlap.
Yes, sir.
What are the two functions?
It's right on the left hand side. I think this is better.
R equals 2 minus 2 cosine
Uh-huh.
theta
Uh-huh.
-6 cosine.
How do I make it move?
You can not on the graphing calculator. On Desmos you can, but you can't make it move.
No, but like, everything else is spinning.
It doesn't. It doesn't. The graphing calculator is shitty, so they cannot do what Desmos can do.
All the big ones.
Not even TI Inspire, right? They don't have slider, right?
It says it. Figure out how to make it move. It says 0 to 2 pi, like 0.13. Trying to see if I can make it like stuff. Oh, slider? Oh, oh. Wait. Oh, never mind. I'm retarded.
Should we find out where they're equal?
How do I get rid of this?
That has to be enough. And we go from it. Yes, it's not equal to just.
I got -1/2. So that's at
2 divided.
that's
You find, I think you find where they intersect and like. You're good. So.
Oh yeah, yeah. Oh yeah, let's see. Oh yeah.
Yeah, because
Oh yeah, you just divide it to multiply by 2.
it's gonna be Wait, I got it. We got it.
I guess
Where's that? -1/2. Wait, cosine is. Here, 1 second, 1 second. So yeah, 4 pi over 3.
so it's 1/2.
5 pi over 3. So it's 9 pi minus integral from 5 pi over 3.
Is 9 by the area?
Yeah, so 5 pi over 3. No, 4, okay, 4 pi over 3 to 5 pi over 3 of the 2 minus 2 cosine.
Got what for big?
4 pi over 3.
That's where they intersect.
Look, because then the second one. Just that. Actually, first we see if I can.
I'll try to.
I'll see if I can get it right
all
first. Maybe see if I get this right.
I don't know how to account for like
You have to split it into 2 different. Or I'll put it off a table. So you have 4.
Oh shoot.
Oh, you have to divide. Oh, yeah,
what about all this?
but you only have to do up to 4 point. Because
No, the problem is the curve.
you just
The
do.
first one you got was 9.
But yeah.
The answer 8 pi plus √3 over 2.
Nope.
It's the,
Yeah, because it's the curve part of it.
Come on, this could be a team question right
Yeah,
here.
yeah, I don't know.
it's like we have, so if you have like this, we found the area of that, but we need
But we need
the
the
area
curve. Yeah, exactly.
of that. I don't know how to find it.
And then he's.
It's like a team on Saturday.
We found like the arc length. Yo, wait. Okay, what is the length of what is R at 4 pi over 3?
What's this way? This is 5.
What's cosine of 4 pi over 3?
I think it's gonna get harder.
That's 2 plus 1. Okay, that's 3. So what's the circumference of the circle? What's the radius of the circle? 2? No,
Oh,
it's 3. So 6 pi is the circumference. And then we have-
Austin, you need to know how to do this.
Alright, how do you find a vector of a circle using? Can you do that?
Don't use arc length.
But
Right.
it would work, like theoretically.
No, because the arc length here is not necessarily circle.
But it would work.
Yeah, but not with the corduroy graph.
Well, we already found the part without the arc. We just need to add that part with the arc.
Let's say, does that have to be in terms of pi or can it be different?
Term pi.
Get,
What'd you get?
decimal.
Okay. What'd you get?
Here, read me the decimal. It's divided by.
Give me a decimal. I told you it's right or wrong. Huh?
73.5.
No. That's way too big.
Yeah, how probably how we get rid of the curve part.
No, you can do two different angles. I think it's okay, but
Explain your thinking.
okay. You do so from pi over 2 to 4 pi over 3, right? Only do integral blue. Does that make sense?
Wait. Okay.
So where they intersect, only do integral blue. And then from that point to what do you call it? Pi, only do integral red. You multiply that area by 2. So like from here to here, only do integral of blue, and then from here to here, only do integral of blue.
Right.
And then multiply that by 2.
But I think that's. You said yeah.
Yeah, I like that. But that's not. What did you do?
Pi over 2. 4 pi over 3.
Because it's it wouldn't start at pi over 2 because the circle would shift to the left. So what would the actual like angle be for that? I think that's would it be because it would be that looks like 5 or 3 maybe. I don't know. So integral
But then does that make sense?
Kind of.
0 to pi over 3. So 1/2 of 0 from 0 to pi over 3 of what is that one? It's the big circle is the cosine, right?
Uh-huh.
Oh, that's what I did wrong. 2 minus 2.
Oh, I did some I found it.
P theta,
I see what I did.
and then plus
Oh, is it 40?
I don't think so. Something less than 20.
from what did I say from 5 or 3
Between 20 and 10.
to
15. So there.
So only
Should I give you a hint or no?
from here all
Yeah.
the way to here. We're gonna do integral blue.
Austin, good work.
Only blue. And then from here all the way to here, you're gonna do integral blue.
Then you add that.
And then just add and multiply by 2. Yeah.
And then 9 pi to 9 pi. That's wrong.
Wait, 9 pi minus 2.
Minus what you just. Yeah, it's just that way. Can I see?
No, that's the area of it.
So
is it like 0.6?
No.
yes.
The way it works. I think it just means
Is it 2 pi to minus 3 plus 2 root 3.
So that makes sense there.
Yeah. Yeah, yeah. Gotcha.
No. It's more than that.
Within 13 pi.
It's more than.
It's greater than 13 pi.
The answer is between 10 to 20. I'll give you a hint. Should I or no?
I'm on the right track.
You need an auxiliary line. Auxiliary line. The line to help you solve the problem.
That's what I was doing. I just can't. That's what I was doing with the arc length. Like we found the green area, we just don't know the blue area to the right of it.
That's not arc length though. That's
That's
area.
On the area. No, you don't have to do arc. You just do the area of red from that. That's which is what I did, but I don't know. Just do area of the red shape from 4 pi over 3 to.
Alston, you.
Not 4. Oh, it's not 4 pi over 3, 2 pi over 3. Don't see.
2 pi over 2.
2 pi over, no, oh, that's why, because it's 2 pi over 3.
What?
What?
I messed up. Because when you set them equal to each other, it's a 9.
5.
I got 4 pi over 3, 5 over
4 pi over 3 is right.
4 pi over 3 is right.
2 pi over 3 is an intersection.
Yeah, 2 pi over 3.
Oh, because it's cosine.
Is it 5?
It's 2 pi over 3 is 4 pi.
12.56.
You're getting closer, but it's not right.
Is it 5? Is it 15.7? Right there you go. Yeah, I messed up the balance.
Wait.
And then,
That's at 4.4 pi. I thought that was 4 pi. That's not true.
so,
You still don't know trig. You just said you still don't know trig.
No, I don't.
Oh
I don't know
man.
bounce.
Wait, what did I do? So it's not-
What do you see? What you done?
It's to be
Oh, we have multiple. Oh no, you don't.
wait,
Why do you have 9 What's the 9 You're not subtracting. You're just doing.
Oh yeah, well,
yeah.
yeah.
That's right. I have to roll from 2 power 3, 4 power 2, 5 theta squared, 8 theta for the 3 area. Yeah. And then plus 0, 4 power 3, or sorry. 0, 2 power 3. Oh. I dropped 1 half. It's so
Why are the functions so
weird.
this should be 2 marks.
Yeah,
Where do you get those?
it's -6 cosine is big circle.
Yeah.
So that's the big circle. This is too much because that's the red.
You got the right. You just plug it
Yeah,
in the wrong.
wrong function. But in any event, small circle, or not small, but red shape, blue shape.
Yeah.
Yeah.
Well, they are.
But there, it's easier just to do all the way up to pi than multiply by everything. Yeah, it's kind of the same stuff.
Okay, so
So instead of,
Yeah,
that's what I did.
it's all up to pi.
Here and there.
Well, no, you start. Your lower bound starts here. You go to your lower.
Right.
bound, go to pi. I mean, same thing. Not that much different.
Yeah, I guess 6. Wait, okay. Yeah. Makes sense.
okay, this is your homework. It's a multiple choice. And this is all gonna count as grade, so
Unit circle.
Daniel, can you help me post on group chat? First 28 questions, and then do you guys understand the polar function now?
Yeah.
Austin is not awake yet.
You said first 20.
Mhm. Are you talking about individual tests?
No, I'm talking about my ring. I got my ring.
Oh, you got rank. 25 is kind of low. For
I
you.
don't think so.
Oh, you didn't take a lot of AP class.
No, but it's up until. I probably did take more AP classes.
You can actually tell Philip to change your grade or improve. Tell Philip to change your grade. It's a Phillips, right? I'm gonna get Dora.
You did a lot more than drop. Yeah, I dropped my computer too. I dropped my computer. Is this your phone too?
Because I keep getting 2.5 with the entire, like this entire section.